Hello student, so welcome to Sir physics class. Already we have started the fourth chapter, okay, that is moving charges and magnetism. Now we will continue the same the next part of this chapter. Already we have seen when the charge particle enters into the magnetic field, so the force is given by F is equal to what? QVB and sine theta. Okay, so this much of force is applied on the charge particle Q if it is moving with velocity v in the magnetic field B at an angle of theta. Okay, and when the force is maximum when theta is equal to 90 degree, and when the force is minimum on that charge particle when theta is equal to what? 0 degree or 180 degree. Okay, so those equations I have already written here. Okay, so next is we know that definitely that when the charge particle enters in the magnetic field, okay, unlike suppose I will show you here, this is the magnetic field. Okay, this is the magnetic field, and if the charge particle, positive charge particle, suppose this one is positive charge particle, is entering in the magnetic field, entering in the magnetic field with velocity v. Okay, so maybe it will deflect maybe this side or maybe this side. Okay, depending on the what, the Fleming's left hand rule and right hand rule. Okay, so once it is deflected means what will happen to this charge particle after the deflection? After the what? Deflection, whether it will trace any other path, okay, or whether it will just move or come out from this magnetic field. Okay, so that we are going to learn it today. Okay, it means what? Motion of a charge particle, you can see the heading here, motion of a charge particle in the magnetic field. Once it enters, what will happen to the charge particle motion? Whether it will continue move in the curve path, or whether it will take the circular path, or maybe whether it will take the any another path. Okay, so remember this equation, that is first equation, how much force is applied on the charge particle when it enters in the magnetic field. And this one equation we are going to use, and this equation is nothing but the centripetal force. Okay, so centripetal force is already you have learned in the first year, that is the force required to move the object in a circular orbit. Okay, if anything or any object is moving in the circular path, okay, or circular radius. Okay, so the force responsible for this circular motion is nothing but the centripetal force. Okay, so this force keeps the object in a circular orbit. This force keeps the object in circular orbit. Okay, so now you can read here. Okay, when the charge particle Q enters in the magnetic field, it experiences the force, magnetic force, and that force is how much? F is equal to what? QVB, and according to that it will deflect. Okay, next is due to this it bend or changes its direction, and after that it move along the circular path. Okay, so I think you will come to know that if suppose this is the magnetic field. Okay, so this cross means what? Magnetic field is moving into the paper, into the papers. That means all the magnetic field lines are moving perpendicular here, but into the paper, not out from the paper. Correct? Okay, so this is what the you can have this magnetic field lines. Okay, so I will represent it as this is B vector because magnetic field is B. Okay, now suppose any charge particle is entering from this side, maybe positive charge particle Q. Okay, and it has a velocity v. Okay, if this is a charge particle Q is entering in the magnetic field, I think it may be a perpendicular, then this charge particle will experience the force here. Once it enter in the magnetic field, it will experience the force, and due to this it will trace a curve path. Okay, but here is also magnetic field, so once it here, it will apply again the magnetic force. So here it will apply the again magnetic force, here it will again apply the magnetic force. So this charge particle will rotate in the circular format. Okay, it will take the circular path, it will take the what? Circular path with radius r. Correct? With radius r. And then okay, so now if it is entering perpendicular, okay, if the charge particle enters perpendicular, that means theta is equal to what? 90 degree, then it will take the only circular path, then it will take only a circular path of radius r. Correct? Okay, so now we are going to derive the derivation for this radius. What should be the radius of that circular path? Okay, so now at each point, if you consider the point here, okay, suppose if I consider the point here, okay, so the force is always inward, magnetic force is always inward. If the particle is here, magnetic force is again inward. If the particle is here, magnetic force is always inward. If the particle is here, magnetic force is inward. Okay, so due to this rotation, it will experience the another force that is nothing but the centripetal force. Okay, so at each point there is another force, that is centripetal force. So here is also another point, another force, centripetal force, and here also another force, that is centripetal force. So you can see here this centripetal force and this magnetic force, that is, I will say FB. Okay, so this centripetal force and this magnetic force both are equal, but opposite, and this centripetal force is responsible to keep the object in circular orbit. Okay, so from this analogy you can say that the force, the magnetic force is balanced, magnetic force is balanced by the centripetal force, by the what? Force centripetal force, which keeps the which keep the charge in circular orbit, which keep the charge in circular orbit. It means what? Both the forces must be equal. FB is equal to what? FC, correct? So magnetic force equal to what? Centripetal force. So it is entering perpendicular, so theta is equal to 90, so sine of 90 becomes 1. So FB is equal to what now? QVB. Okay, sine of 90 becomes 1 is equal to what? FC is nothing but, I told you that this is the equation for the FC, so it becomes what? mv square by r. Okay, so 1v will cancel out, so r, take this r this side, so r is equal to what? mv divided by qb, so this is the expression for the what? Radius of this circular orbit, circular orbit, correct? Okay, it means what? This radius depends on the what? Mass of the charged particle, velocity of the charged particle, and charge, how much charge is present on the charged particle, and then b, correct? So I will write it down here, on which parameter it depends, okay. Suppose if mass increases, if velocity increases, so both mass and velocity are directly proportional, so automatically r is also increases. More mass, more radius. Okay, that means if there is another particle having a mass more, it will trace maybe this bigger circle, because radius will be directly proportional to mass and the velocity. And if charge is more and magnetic field is more, okay, so you can see here radius is inversely proportional to this q and b. So if charge is more, radius is small, and if the magnetic field, external magnetic field is more, then the radius is also a small, correct? Okay, so this is what the expression that is today we are already learned. Okay, next is once this expression is derived, okay, so this expression will tell you what? When the charged particle q enter with velocity v, it trace circular path of radius this much. Okay, so where m is nothing but the mass, if it is electron, mass of the electron, velocity of the electron, charge on the electron, and in which magnetic field it is entering. Okay, so next one is we will see, that is different forms of this particular equation. Okay, so I will once again I will write it down. R is equal to what? mv divided by qb. R is equal to mv divided by qb. Okay, so this is the first equation. Okay, so as we know, this one, momentum is equal to what? Mass into velocity. Momentum is equal to what? Mass into velocity. So and kinetic energy is equal to what? Half mv square. I will multiply by this equation by m and divided by m. So this m and m will multiply, it becomes what? Half m square v square. And what about this m and v? It becomes p. So k is equal to what? Half m into v the whole square, correct? So k is equal to what? It becomes p square divided by 2m. Sorry, the m will be here, this m will multiply with 2. Okay, therefore p square is equal to what? 2mk. K shift this side. Okay, therefore p is equal to what? Under root of 2mk. Okay, so this is what the relation between the linear momentum and the kinetic energy. Hence we know that r is equal to what? mv divided by qb. But mv is equal to what? P. So it can be written as p divided by qb. So r is equal to what? But p is, this is another equation, correct? Therefore r is equal to what? P is equal to under root of 2mk divided by what? qb. So this is radius in terms of kinetic energy, in terms of what? Kinetic energy, correct? Okay. This is the only thing you have to learn in this topic, okay? And then if last one is, if charge particle, if charge particle enter into magnetic field, into magnetic field at any angle, at any angle theta, okay? It should not be 90 degree, it should not be 0 degree, it between 0 degree to 90 degree. Then it trace, it trace spiral or spring like, spiral or spring like path, spring like path, or it can be also called as a helical motion. It also called as what? A helical motion, okay? If it is entering perpendicular, it takes circular path, it takes exactly circular path. But if it is entering at an angle theta, at an angle theta, then it will take such a kind of a path. The charge particle will move in a spherical shape, that means like this one, okay? It will take a spiral shape path. It is moving in the circular form, but it has a spring like shape when it is entering not 90 degree, not 0 degree, but any other angle between the what? 0 degree to 90 degree, maybe 30 degree, maybe 45 degree. If it is entering in the magnetic field, then it will trace a helical motion, or it is sometimes also called as a helix. It is sometimes also called as what? Helix, okay? So remember this thing, okay? So this is what the for the today's lecture. So we will continue the next part in the next lecture. Thank you.